With linear functions today. So this is our notes 1.3. And there's really like two parts to today. One is if you're actually writing the equation of a line, like these points are actually on a line together. So we'll review that. And the other part is something called the line of best fit, where there are points out on the graph that are not all on the same line, but they're looking like they're forming or they're following a line, and so we make a line that models those points. It won't be those points exactly, but it's a good model for that. So today is modeling with linear functions. Are you familiar with any equations of lines? Does anybody know any equations of lines? What's an equation of a line? Annie? Sure, that's probably everybody's favorite equation of a line. We're going to do that example here in a minute. So this is called slope-intercept form. Y equals mx plus b. And it's called slope-intercept form because you know the slope and which intercept? The y-intercept. Okay, good. M is slope and y is, or b is y-intercept. Does anybody know any other equations of line? Luke?
Isn't there a point slope form?
Yes, there is something called a point slope form. So we're going to put that up here on the board. Point slope form. Okay, point slope form you can use when you know a point that's not necessarily the y-intercept and the slope of the line. And it looks something like this. Y minus y sub 1 equals m times the quantity x minus x sub 1. And it looks a lot more terrible than it probably really is. The nice thing about this is m is always our slope. And then x sub 1 and y sub 1 is any point on your line. So again, you could even use point slope form if you knew the y-intercept. It's just that you'd have to do a little bit of simplifying and you get the same answer as y equals mx plus b. But you could write an equation point slope form for any point on the line. It doesn't have to be the point that's on the y-axis. Okay. Now I am going to, off on the side here, I'm also going to make a quick note because we're going to need to do this. Does anybody remember our formula for slope? Abby? Yeah, y2 minus y1 over x2 minus x1. And don't get caught up or hung up on like two is first and one is second. It doesn't really matter, right? As long as you do the same order in the top and bottom. You may be taking physics someday, and in physics, they're going to use a notation. I'm running into my line there, but it looks like a triangle. It's called delta delta y over delta x, where delta means the change in y. So the change in y over the change in x. It's up to you. I'm just showing it to you now because a lot of you will take physics at some point, and so I'm showing it to you. So when your physics teacher talks about it, you might be like, "Okay, I've seen that before." Okay. Delta in science and math just means change in. So a change in something is like subtraction, right? Okay, so good to know. If you like the mathematical formula for slope, that works fine. I even, like after you do slope so many times, I even shorten it. It's just y minus y over x minus x. We're in Algebra 2, so we remember to put them in the same order. Okay, now let's do an example. This is a quick example or like a basic example from Algebra 1. Let's write the equation of a line that passes through these 2 points. 2, 1, and 10, 5. So write the equation of a line that passes through these 2 points. Now, we wrote down 2 equations of lines, the slope-intercept form and the point-slope form. What do those 2 equations have in common? They're both forms, and they really have the slope in common. So no matter what, if you're going to write the equation of a line, you really would like to know its slope. So let's calculate slope. M equals, if we follow Abby's formula where we do y2 minus y1, we would do something like 5 minus 1 all over 10 minus 2. So we get 4 over 8, which is 1/2. Okay. Now, I'm just going to illustrate here for us. Either method works. If you were taught to write equations of lines with slope-intercept form, you can use slope-intercept form, or you can use the point-slope form. It's good for you to be familiar with both. A lot of higher-level math classes are going to use the point-slope form, especially if you have to take a math class in college. Your college professor will use point-slope form. But I know in Papillion La Vista, it seems like in middle school we learn just one form of line because it's easier. And so we all just use slope-intercept form. That's also okay, but you got to be able to work in either one. So I'm going to show method 1, the way I think most people learned how to do it, and that's y equals mx plus b. So if you're going to use the slope-intercept form, you found out that m is 1/2. Now you're going to plug in for x and y, and you can choose either point. You guys want to do 2, 1 or 10, 5? 2, 1. Okay, so we're going to do 2, 1. So this is our x and this is our y. So we say 1 equals 1/2 times 2 plus b. That's 1 equals 1 plus b. So b equals 0. So then my equation on my line is y equals 1/2 x plus 0, but I don't have to write that down. Okay. The other method, so I'll do method 2, will be point-slope form. And in point-slope form, we would call, if we were going to use 2, 1, and we could use 10, 5, either one works, right? So we'll call this x sub 1 and y sub 1. Then I'll write something like this. Y minus 1 equals 1/2 times x minus 2. Now, if it's not specified, truly, you could leave your equation of a line just like that. That is an equation of a line. If it's specified that it should be in slope-intercept form, then you should clean it up. Before you add 1, I would distribute, but you could add 1 there if you wanted to. I'm going to distribute into the parentheses. Y minus 1 equals 1/2 x, and then it'll be minus 1. And then I heard an add 1 before, so now we add 1, and we get y equals 1/2 x. So truly, it's the same line, right? They have the same y-intercept and the same slope. So you can take your pick. If you're like, well, I'm used to doing it method 1 and I like method 1 and I know to plug it back in, that's fine. If you want to challenge yourself and try point-slope form a few times, you could do that on your homework. Okay? Does anybody have any questions about that? How about my people in the back? Can you see everything? You need me to move it up? Our desks are kind of funny because we were quizzing in pre-calculus, so you're kind of out of your normal spot. Really? I feel like you guys are really close to me. Really? Make this a little bit bigger so you can see it. Okay, the graph on the right, and you're going to have some of your first problems on your homework are going to look like this. The graph on the right shows the remaining balance Y on your car loan after making X monthly payments. Write an equation of the line and interpret the slope and the y-intercept. So go ahead and take a little bit of time, look it over, think about how you might be able to write the equation of think about what are slopes, what are y-intercepts. I'll give you a little bit of time on your own just to think about that. Alright, have a chat with your group now. Were you able to come up with an equation of a line, or what would you do to find the equation of a line? And if you guys have an equation of a line, then move on to the second part. What does the y-intercept mean in this scenario? What does the slope mean? So go ahead and talk with your group member first.
Don't show up. But then I have to come back for this
Okay, so when we get a problem like this, where it's put in the context of some application, there's like a story or words that go along with it. I mean, remember that you have some basic skills, just like if you had 2 points, you could write the equation of a line, right? So first thing you would do is it just the last name that you're doing, Chloe? Is your last name McIntosh? She already has her. Oh,
I'll take it.
I'll take it.
I'll take it.
Here we see.
okay. So you could calculate slope. Okay. M equals, and you might do 15 minus 18 over 10 minus 0, so that's negative 3 over 10. You could write that as negative 0.3 or negative 3/10. Either one is fine. And then to write the equation, you could sub into one of the equations. So we could say x and y, right? And do something like 18 equals negative 3/10 times 0 plus b. Oh, well, b is equal to 18. Some of you might have also recognized, like, that's the y-intercept on the graph, isn't it? So you didn't even do that work. That's okay. So it's okay to work smarter, not harder. Other people might have recognized because the x value is 0, and then you're going up 18, that would be on the y-axis, so that is your y-intercept. Okay, so be thoughtful, you might reduce the amount of work you're doing. But our equation is y equals negative 3/10 x plus 18. And then we're supposed to interpret the slope and the y-intercept. So what's the y-intercept supposed to be in this application? Taylin? Starting amount. Okay. So let's say, I'm going to say beginning amount of loan for the initial price of your car. Is your car just $18? 18,000, because you read the side over there. Okay, so 18,000 is the initial cost of your loan or the initial cost of your car. And then what does negative 3/10 mean? Rise -3, run 10. So you're actually going down 3 and then running 10. But in context of the application or the graph, what does your slope mean for your loan and your payments? Okay, so think about the way you're describing rise and run. Look at the axes and their labels accordingly. Aiden? No? Jacob?
Is it for every $3,000 you pay 10 payments?
Yeah, so you're making 10 payments, and what's happening to the amount of your loan? It's going down $3,000. What's that?
It says balance, not loan. Is it loan balance?
Yeah, it says the balance on your car loan
Oh,
in the words. Yeah. So the slope is the loan decreases $3,000 per 10 payments. Squeeze that in. That's your payments. So you got to put it in context. I like what Mason said, rise over run. Then the -3 belongs to the balance. The balance is decreasing by -3,000, so it's going down by 3,000. And then the 10 is your run. That's horizontally. That's the number of payments you would make to do that. Okay. Last question here on this one. What's the remaining balance after 36 payments? How would you figure that out? Plug 36 in for X. So be thoughtful. Would you plug 36 in for X or 36 in for Y? It depends on that graph. So when you're looking, the payments were horizontal, and that would be X. So we could say Y equals -3/10 times 36 plus 18. Anybody got a calculator and can calculate that for us? After we pay for 36 months would be or 36 payments. If you're making monthly payments, that'd be 3 years later. How much do we still owe? $7.2? Can anybody confirm Rihanna 7.2? Okay, I'm getting a second, yeah? Does that seem right? So how much money is left on the loan? $7,200 remaining. Okay. So on your homework tonight, there's going to be problems. It's not just numbers like that first example we did, numbers on a graph. It's going to be in context of a real world scenario. So you got to put meaning to it, okay? Think about what does the y-intercept mean? What does the slope mean? Does anybody got any questions on that? Okay, now let's jot this down in our notebook. Line of best fit. Have you guys done best fit lines before? Does that sound familiar? Okay, just brand new to you. Line of best fit. Write these things down. Here's the steps to doing a line of best fit. First, you're going to graph the data. That's called a scatter plot. And then you're going to draw the line of best fit. Okay, okay, how do you draw a line of best fit? Here are a couple of tips. The line of best fit should follow your data. So your data on your scatter plot, in order to do a line of best fit, it really should look like the data is kind of grouped together along some line. If your data was just everywhere and looked crazy and you couldn't even see a line, you probably wouldn't do a line of best fit because it doesn't really fit the data. And your line should be in the middle of your data, so you should have about as many points above the line as you have below the line. So you don't want to draw your line above all your points or below all your points. You want it in the middle of all your points. And then the rest of it's pretty easy. Pick 2 points on your line. They may or may not be original points. So just find 2 points on the line and write the equation of your line. That's going to be your linear model. Now, when you use your linear model, it won't always be exact for a data point, but it will be close to your data point. This is how we actually apply our mathematics in the real world. So we'll say this is what we expect to happen. Of course, there's some margin where it might be higher or lower, but it's going to be pretty close to this if it follows the linear model. Now, how well your model works depends on something called correlation of your graph. Okay, so there's something called a correlation coefficient. Now, you don't necessarily have to draw all these things in your notebook. If you want to see them again over the weekend, you could look it up online. I'll post my notes later today. But do you see how some of these, like this data right here, don't you see how all these points are kind of grouped along and going down? And I could really like draw a line right through the middle of those points. And I would feel pretty confident that my data was following a line. Okay. And then it's getting weaker. This is just in the middle. It's just kind of everywhere. It doesn't really look like anything. So I'd say it doesn't really have a correlation. And then I've got a weak positive and a strong positive where it looks more like a line. Your correlation coefficient is the letter R. When there's no correlation, R is equal to 0. There's 0 correlation. No good. When you have positive correlation, your R value is positive, and I almost think about R like a percent, like what percent of my data is on or close to my line. So as my correlation gets stronger, it's closer to a line. If you had an R value equal to 1, all your points lie on the line. If you have an R value of 0.95, all of your points lie really, really close to the line. Okay. And then if your data looks like a line that would have a negative slope, then your R value is closer to what? Negative 1. So correlation coefficients go from -1 to 1. The closer you are to the extremes, -1 and 1, the closer you are to an actual line. And then when you're in the middle, you really don't have any kind of pattern at all. Okay, so if I were just to like look for a line, I mean, I could draw a line going down or going up or who knows, right? Doesn't really look like a line at all. Okay, so you're going to be asked to do lines of best fit on your homework. Oops, I don't want to do that. Sorry. Where's your femur?
Your thigh bones.
Yeah, it's your largest bone in your body, I think. Okay, so we may or may not get done with the full example here, but you have a piece of graph paper. Okay, get that graph paper out. And if we were asked to see if this data is linear, zoom out. You can use like a side of your notebook or a binder as your straight edge for me. Notice that all of my data points are positive, so I'm only going to draw a first quadrant because that's where positive things are. My femur length is X, and my height is Y. What should I scale by? Tens? Okay. 10, 20, 30, 40, 50, 60. Anyone do tens on the other one? I don't know if I have 20 there. So let's go by 20s maybe? Is that okay? 20, 40, 60, 80, 100, 120, 140, 160, 180, and 200. These are going to look different depending on what you choose to scale by. That's okay.
You forgot the 90.
Well, I'm scaling by 20s.
Oh, I'm sorry.
It's okay. Now plot your points. So the first one is 40, 170. And 45, 183. And 32, 153, 151, sorry. Um, 50, 195. 37, 162. Is this looking like it might lie on a line?
Yeah.
It's looking pretty good right now, right? Okay. 41, 174. 30, 141. 34, 151. That's kind of on top of that other one. 47, 185. And 45, 182. Kind of right on top of that one too. What do you think your R value is close to here? Probably pretty close to 1. It's probably like 0.9 something. This is a pretty good line. Okay. To draw your line of best fit, you would take a straight edge, okay, and get it in the middle of your data. Well, this is going to be pretty nice because my data is really close together. So just kind of make it go through my data there. So I'm going to go something like this. Okay, so I've got some that are below and some that are above. I maybe should move my ruler back so I was closer. And then it's up to me which points I pick. But I should pick points on my line and then make a line of best fit. So I like right here, it looks like it's passing through this like grid mark, which would be 5,200. So I'm going to use 5,200. I'm going to put that up here on my smartboard. I'm going to use, oops, sorry. I need to do that. Okay, I'll put it right here, and then I'll come back to it. So I'm going to do 5,100.
200.
Oh, 200, thank you. 5,200. And then I can pick, gosh, label my points, but it looked like it goes through this point right here, which that must be my 41,174 because it's really close to 40. Okay, so I'm gonna circle that point, this point right here. Okay, so I said this point was what, 5,200, and this point is from my table 41. What is it? 174. Well, 5195 is in the data, but I think that my line is really going through like the lattice point of the coordinate plane. So remember, in the line of best fit, the points you choose on the line may or may not be data points. It's okay if they are, and it's okay if they aren't. But you need to pick 2 points that are on your line. And my line may be slightly different than the line that you drew, right? We're all drawing our own on our paper, and we're not doing this with technology. So yours is going to be slightly different, but we should have, especially in this example, we should have slopes that are really close to each other and y-intercepts that are within a reasonable distance of each other. So the bell's going to ring shortly, but if I had those 2 points, could you write the equation of that line?
Yes.
Yes. So we have 50. That's not what I want to do. 5,200 and 41,174, and then we would write the equation of the line. So calculate slope and then plug in. Okay. You have a homework assignment. Use this graph paper if you want to do your scatter plot. I think there's only 2. 1 or 2 that you have to do the scatter plot work for. The other ones are going to be like the one at the beginning where it's just like they give you a graph, you calculate the slope and the y-intercept and give it meaning, okay? You guys did good today. Thank you. Have a good weekend.